Chapter 11.2, Finding the Midpoint. This chapter is going to be over midpoint. Midpoint might be familiar to some of you, and we might come up with some new geometry terms here. Let's start with our vocabulary. Our midpoint is a point on a line segment halfway between the endpoints. So if we have a line segment here, let's say from A to B, the midpoint has an equal distance here from A to the midpoint, let's call it M, and an equal distance from M to B. So it's halfway between the line. The median, we're only speaking about triangles here, is a segment from the vertex, so the corner of a triangle, to the midpoint of the opposite side. So if we call this C, this is a line going from C to M, where M is the midpoint of line AB, the line segment opposite of vertex C, vertex being a corner again. And then a perpendicular bisector. A perpendicular bisector is just a line that passes through the midpoint of a line segment. So let's say this point M here is the midpoint of this line segment AB, and then this line here is perpendicular to AB. So we know from 11.1 that our slopes would be negative reciprocals. So let's try it. We have a triangle here with vertices A at -4, 3, B at 5, 9, and C at 0, -3. So let me plot that. There's my triangle. We are asked to write an equation for the median of vertex B. Okay, so the median of vertex B would go from B to the midpoint of AC. So first, I'm seeing that we need to find the midpoint of AC. We can estimate where it is, but we're going to use something called a midpoint formula. So the midpoint formula is when you take the x value of your endpoints and divide by 2, and then you also take the y values of your endpoints and divide by 2. So we're just averaging the x's and averaging the y's. So we're asked to find the midpoint of AB. So I'm going to take -4 is my x1, and C, the x value at C is 0. So 0 is my x2, and divide that by 2. That's -4 divided by 2. That's a -2. So that is my x value of my midpoint. And then we're going to take and average the y's. So I have a y of 3, y1 of 3, and a y2 of -3. So 3 plus a -3 divided by 2, that's 0 divided by 2, which is 0. So that's my y of my midpoint. So at -2, 0, that would be the midpoint of AC. So our median is going to be the line connecting that midpoint M to our vertex B. So we're asked to write an equation for this red line here, this median. And if you remember back in chapter 4, we have two ways to write a linear equation. This is a line, so we're going to write a linear equation. We can do y equals mx plus b, where m is our slope and b is our y-intercept. But I'm seeing that our y-intercept isn't nice here, so we might have to calculate it. And we could probably estimate that it's 2.5. But we also know that we have slope or point slope form, which is y minus y1 equals m times the quantity x minus x1, where x1 and y1 are just a point on the line. So we have a point on the line, and we can find our slope pretty easily here. And I'm just going to write it in point slope form then. So let's calculate our slope. Our rise from 0 to 9 is 9. Our run from -2 to +5 is 7. So we have a slope of 9 over 7, which cannot be reduced unless we want to take 1 2/7. Okay. and we have a point on the line which is -2, 0. So if I plug that in here, I have y minus 0 equals 9/7 times x minus x1, which was -2, minus a -2. Okay, so that's just going to be y equals 9/7x, and then if I distribute the 9/7 into there, and then if I distribute, this is going to be adding 2, so that's a positive 2. 9/7 times 2 is going to be about 2.57. Okay, so we could leave it there. We have our slope-intercept form. So our y-intercept, this is actually about 2.57. So if we would have just estimated, we would have been a teensy bit off. Okay. Now we're asked to write the equation of a perpendicular bisector for AB. So I see right away, perpendicular bisector, if we review from before, is a line that is perpendicular to a line segment and goes through the midpoint of that segment. So we need to find the midpoint of AB. So we're going to use the midpoint formula and take our x1, y1, x2, y2. If I average my x's, -4 plus 5 divided by 2, that is 1 divided by 2, so a half is our x value of the midpoint. And then 3 plus 9 divided by 2, that's 12 divided by 2, that's 6 equals the y of our midpoint. So at 1/2, 6, this point right here is our midpoint, and we're asked to write an equation for a line perpendicular to that line. So we need first to make a perpendicular line through here. So we need a line that goes through this midpoint, but we also need a line that is perpendicular to AB. Now we know that perpendicular lines have slopes that are negative reciprocals. So we need to find the slope of line AB. So the slope of line AB, or M, and I realize this is a little confusing with midpoint as M2, so I'm just going to write slope. The slope here, we need to go from, we rise from a 3 to a 9, so our rise is 6. We run from -4 to +5, so we have a run of 9. 6/9 reduces to 2/3, so we have a slope of 2/3. All right, that's the positive slope of AB. We need the slope of our line to be the negative reciprocal, so we need -3/2 to be the slope of this line. All right, so I'm going to start from our midpoint 1/2. So from this line, I'm going to go down 3 and over 2. So 1, 2. And that is my line. And again, I'm going to write this equation in slope-intercept form, or point-slope form, since we know we have a point here at 1/2, 6. And we have our slope, which is -3/2. So we have y minus 6 equals -3/2 times x minus a half. And to reduce that, I will distribute the 3/2, and then we will add 6. And we have y equals -3/2 x plus 6.75. And that looks about right if we look at where our y-intercept is. Okay, for class, we would like you to use the slope and the midpoints to construct a perpendicular bisector of BC. And you're given the 3 vertices of A, B, and C here for this triangle.